Hello and welcome to the 7th lesson in Spiral 3. So today we're looking at direct variation. Direct variation, so very important. All right, we're going to talk about its partner in the next lesson. So today is just direct variation. So I want you to be able to identify it and do a little bit of work with it with graphs, equations, and t-charts. So those are our three ways to represent that. So taking a look at the first page of the note here, a relationship that shows a direct variation is when one quantity is just a multiple of the other. And I'll show you that in the t-chart here in 1 second. We can say we're just multiplying the x value to get the y value. This type of relation always goes through 0, 0. So 0, 0 is our origin. So let's take a look at the t-chart here. So I'm going to build the t-chart from my graph. So at x equals 0, the y value is 0. At the x value of 2, the y value is 40. At 4, it is 20, 40, 60, 80. At 6, it's 120. So what is the pattern here? So what is my first differences? Well, we see that it's going up by 40 each time. So it's going up by 40s. So that means the next one will be 160. And the next one will be, oops, even 200. 200? Am I counting up by 40s, right? Yeah, 200. All right. Okay, so before we go and finish off the fill in the blanks below, let's talk about how you come up with the equation. So remember, back in earlier in this unit, we talked about how to kind of develop equations. So basically what you do is you take your x value and you multiply by your first difference. Multiply by first difference. Okay, I don't like the way that's looking, so let's do it this way. So it's going to be x multiplied by first difference plus some value equals your y value. Always works. So if we look at this one, so we go across here, so at x equals 0 times 40 plus blank equals, and the y value was 0. So I just took this one right here. Next one, 2 times 40 plus blank equals 40. What am I doing wrong here? Looking at it, it's 2, it's 40. So it's my first differences. Oh, this is a tricky question. Tricky question. Okay, they have played a bit of a trick on me, and I don't know if you've caught it. We are going up. Our first differences are, yes, it's 40. However, we'll notice that we're going up by 2's over here. So this is the problem. So what is my true first differences? So this is actually, we're not going to erase it because you've already wrote in it. But the first differences are technically not 40. They are going to be 40 divided by 2, because you're going up by 40, but you're going up by a time of 2. So the first difference should be 20. That's a nasty or dirty little trick. That's a definite EQAO question there. So now we do have to kind of erase that because we now have to go up by 20. So hopefully you can see that your first differences, it only works when your x's go up by 1. When they go up by any other number, like in this case plus 2, then we got to divide whatever the y's are going up by the x, because we really want to go up 1 to 1. You can go over to your graph here, and you can figure it out this way as well. So for example, the y values went up by 60, and 1, 2, 3. So it went up 60 for every 3, or 60 divided by 3 is 20. Ooh, dodged a bullet there. I almost messed that up. Still, filling out the chart properly then, we know that 2 times 20, oh, now I messed up again. Sorry, that should be a 0. And 2, oh boy, not a good start here. 0, 2, and 4. There, that's lots. All right, so when we look at it, 0 times 20 is 0. I want it to be 0, so my constant is 0. So 2 times 20 is 40. Then we want 40. So what we find here is that the constant is 0. So the equation, or the formula, so to speak, is first difference times x equals the y value. All right? So that ends up being our general formula. So filling in some blanks. Properties of a direct variation. So direct variation, it goes through 0, 0. It goes through the origin every time. 100% of the time, all of the time. The y column is just a multiple. So we're just going to multiply by something to get the y value. Multiple, I guess, better spell it right. And you can get the y values by multiplying the x values by the first difference. I don't know why there's 3 dashes there. All right, so there we go. Bit of a mess up here. You can see that I get tripped up. So just keep in mind when you go to do EQAO or this test, you need to make sure that table of values isn't misleading. All right. Okay, flipping over. So I think we have an example to work through. So Brooke, she gets paid for making beaded necklaces. She gets $9 for each necklace she completes. So complete the table showing what Brooke would be paid up to 50 necklaces. All right. Well, we're going to do this a little bit different here. So I'm going to say if Brooke makes nothing, she gets paid nothing. All right. It wants us to go up to 50. We'll deal with that in a second. One necklace is $9. 2 necklaces, 18. 3 necklaces is 27. 4 necklaces, so 4 times 9, she gets paid 36. And then 5 necklaces, she'll get a cool $45. Okay? The reason I'm ignoring this instruction is because it causes me problems. I want to go up by ones, so I'm going to cheat a little bit here. So going up by ones, well, that's 9 plus 9 plus 9. And this is going up by ones, so therefore, I'm just going to put right here, first difference equals 9. All right. So complete the table up to 50 necklaces. So let's write an equation for this relationship. I'm going to do this a little bit out of order, just because we can, because we are mathletes and we can do whatever the heck we want. So I'm going to skip down to D, write an equation for this relationship. So off to the side here, beside the graph, I have room. So again, we know that in general, it is our x value times first difference plus a constant to get the y value. So you'll be able to skip steps, I know, in the homework here, but at this point I'm showing all steps. So for the first couple, 0 times 9 plus blank is 0. Using the next one, so 1, so I'm referring to this right here in the T-chart. 1 times 9 plus blank equals 9. 2 times 9 plus blank equals 18. So I just want to do a couple to make sure we get it to work. So 0, 9, 18. So in every case, we're adding 0. I know it's shocking. It's almost like whatever I said on the first page of the note is the same as it is on this page. So skipping down here, my equation, y equals x multiplied by first difference. Y equals x times first difference. All right. So now, 50 necklaces. So therefore, y equals 50 necklaces. My first difference is 9. So it's going to be $450 for the 9 necklaces. All right. So that answers A. By the way, I'm going to probably, when I set up the test, I'll be doing this in the right order. So, graph the data. So this is just a matter of graphing it. X-axis, hey, this is a very small grid, so you'll do a little bit cleaner job with your pencil. X-axis is always on the X column, always on the bottom here. number of number of necklaces, and up on the y-axis is dollars. So we're going to graph that data. I'm going to go and make 1, 2. I'm going to spread this out so it's a little bit more space. What am I going up by blocks? It's not even consistent blocks here. So let's try that again. So if we go every 4 blocks, 4, 1, 2, 3, 4, 4. So 0, 1, 2, 3, 4. Number of necklaces. And going up the y-axis, let's go up by every, I don't know. Let's go up every other one is 10, 10, 20, 30. Like I said, with a pencil, it's a little cleaner. 50, 60. So plotting the points, we'll do it in a different color. 0, 0, 1, 9. And it's going to be approximate. You're just graphing as best you can. 218, 327, somewhere in there, and 436. It's close. So we can see it forms a line through the points, goes through 0, 0. All right. So A is done. B is done. C, what is the rate of change? So what is rate of change? It's the first time we're going to see that terminology. Rate of change, and this is important, equals first differences. All right, so your rate of change equals first differences. So how would you answer this? What is rate of change? So I shorten it up. I don't like writing out a whole lot. I apologize. I'm going to finish the answer over here. So rate of change, rock. Rock equals $9 per necklace. This is a unit rate. Okay, so adding to this, which is equal to a unit rate. So, pretty cool how everything comes full circle for us in this course. So that would mean that rate of change equals first difference equals unit rate. So those three terms, they mean the exact same thing. It's just a different way of saying the exact same thing over and over and over again. Okay, so let's finish this up. Use your equation to find how much she would be paid for 120 necklaces. So from D part, y equals 120 times my unit rate of 9. So 9 times 120. 120 times 9. So we get $1,080. Okay. Therefore, and finally, use your equation to determine how many necklaces she would have to make if she wants to earn $2,000. So our formula is y equals x times first differences. I know the first differences, it's always 9. Now we're talking money, so that means the y value is 2,000. This is why we do solving equations already. So this would be 9x. 9 is your first differences. I always like writing the number in front. Makes more sense to me. Divide both sides by 9. So 2,000 divided by 9 is 222.2. Is she going to make 222.2 necklaces? No. So we say, therefore, if she wants to make $2,000, she's got to go up. So I know it goes against rounding rules, but we need to have one more necklace to get there. She must make 223 necklaces to earn $2,000. If she made 222 necklaces, she'd be under that. All right, I got one more short video because I need to finish up the final example.